In this chapter, we're going to go over reactions and their equilibrium. Before we start equilibrium, there are a couple of terms that we would need to define. The first one is a spontaneous process. So a process is said to be spontaneous whenever it takes place naturally with no apparent cause or stimulus. So for example, for the rock to go down the hill, the process is going to be spontaneous. It's normal to roll down and reach the bottom. However, for the rock to go up the hill, it needs force. The process is going to be non-spontaneous. It's not natural for the rock to climb without any force. So if we want to relate this to a reaction, we would say a spontaneous reaction is a reaction that happens by itself without any external interference. So non-spontaneous processes, these are processes that happens when a stimulus is applied. Like here we are applying force for the rock to climb the mountain. So this is a non-spontaneous process. Another term is exergonic process. So exergonic process, this is similar to exothermic, you guys. And we know that with exothermic reaction, the system releases heat. So heat appears in the product. These processes take place when heat is liberated or heat is given up. And you can easily see that heat appears to the right side of the chemical equation. Exothermic reaction means that the energy of the reaction, which last time we defined it to be the enthalpy of the reaction. So the heat here is the energy of the reaction. And the energy of the reaction is basically the enthalpy of the reaction. How much heat the system gave off, okay? So that is equal to delta H. This is the enthalpy of the reaction. So when we say an exothermic reaction, this means that it is that the enthalpy of the reaction is negative. It's the same thing as exergonic reaction. So this is the same term in there, and you can easily see that the heat is going to be shown in the product. This means that the system releases heat. Endergonic process, this is similar to endothermic reaction. So these are processes that gain or absorb heat as they take place. So the heat is going to show up in the reactants because the system absorbs heat. So you're going to see that the temperature of the reaction is going to drop. Here, the temperature of the reaction is going to increase. Here, the temperature of the reaction is going to drop. So that causes the energy of the reaction, which is the enthalpy, delta H, to be positive. So by definition, whenever we're talking about an exothermic reaction has its energy negative. An endothermic reaction has an energy which is positive. This is the energy of the reaction, because the system here absorbs heat versus the system up there, it releases heat. Another term that we want to define is the entropy. Entropy is the measurement of the disorder or the randomness of the system. And the more disorder the system is, or the more mixed up the system is, the higher is the entropy. We define the entropy by delta S, and delta S is considered to be entropy. So if your entropy is positive, this means that the system is more random. So the higher the entropy, the more random the system is. So the system is more random, and the lower the entropy, when delta S is negative, this means that the system is less random. Let's have an example over here. So if we compare between those two pictures, You can see over here that the system is less random. So delta S in there is going to be negative, and we know that this one is going to be a less random system, okay, less random compared to this one. This one is more random because the colors are mixed together. So this one here is going to be more random. More random, this means that delta S is positive. So when you are working with randomness in the system, the higher the randomness in the system, the higher the entropy is. So delta S is going to be positive. So we say that this one is a more random system. So by definition, a spontaneous reaction is a reaction that has less energy, which means delta H is negative, and high entropy. So if I look at the entropy here, if I have an entropy which is positive, what does that mean? An entropy positive means that my system is spontaneous. So I have a spontaneous system. So it's a spontaneous system. Okay, and it is an exothermic reaction because we know that a spontaneous system is always an exothermic reaction, and an exothermic reaction has delta H to be negative. Always the signs of the delta S and the delta H are opposite to each other. Okay, so a spontaneous system always is an exothermic reaction. So immediately you know that its delta H is going to be negative, then the delta S is going to be positive. So a spontaneous system is a system that is more random, on the other hand, if your system is less random, then this will represent a non-spontaneous system or a reaction. It's the same. So we're talking about an endothermic reaction, and the delta H is going to be positive. Again, the signs are going to be opposite for delta S and delta H. Let's consider the three different physical states: the solid, the liquid, and the gas. And the question is here, which system has a higher entropy? Meaning, which system is more random? So we need to look at each one of these at the molecular level. We know that solids, they are made up of molecules, and the molecules are closely packed with respect to each other, right? So there is no room for these molecules to move around. So I would expect that the solid is going to have the least randomness among all the physical states in there. So the solid is going to have the lowest delta S, the lowest entropy. Then coming to the liquid. Now for the liquid, we know that it's also made up of molecules, definitely, and those molecules can slightly move around. Not too much, though. They don't have too much room, but of course they move. They have more room to move than the solid molecules. So I would say that delta S is slightly higher. So the entropy here is slightly higher than the entropy of the solid. Then coming to the gas molecules, we know that molecules here are free to move around, right? So here we have free molecules. So because the molecules are free to move around, this means that the entropy is going to be the highest. So if we want to go ahead and put the order of the entropies for these three physical states of matter, then I would say that delta S of the gas is the highest. The entropy of the gas is the highest because molecules are far away from each other, and molecules, they move freely compared to the entropy of the liquid, compared to the entropy of the solid. For the solid, there is no room for the molecules to move around. So they are stopped in one direction. There is only one arrangement. For the liquid molecules, they are still packed, but not as much as the solid. So the liquid can introduce a little bit more randomness than that of the solid. So guys, remember that the more motion of atoms you have, the higher is the entropy because the more randomness you have. So always gases, they have higher entropy than liquids than solids. And you are going to be asked, okay, what is the sign of the entropy in this reaction? So what you need to look for is what you start with versus what you make. Okay, so you need to look at your reactants, you need to look at your products. So I'm going from where? I'm going from a liquid state, and I know that from the liquid, molecules have a little bit more motion for the liquid, and then I'm going from the liquid to the solid. The solid has no motion at all. So for the solid here, we have no motion versus the liquid, the molecules have a little bit of motion. So in this case, we would say that, look, the entropy of the system is going to decrease. So it's going from the less motion to no motion at all. So the entropy of the system will decrease. So entropy of the system will decrease. So if the entropy of the system will decrease, then definitely delta S is going to be negative because it's going to be less random in this case. And we know that if it is less random, then this is going to be a non-spontaneous reaction. So in other words, I can ask you this, I can give you this reaction and ask you what's the sign of the entropy. Or I can ask you, is your system spontaneous or non-spontaneous? So to answer this, you have to figure out what is your entropy in there, is it positive or negative, and relate that to the spontaneity of the reaction. Another example, going from carbon dioxide solid to gas. So I'm going from the solid state to a gaseous state, okay? So from solid, which is no motion, to gas, which is a lot of motion in there because the molecules can simply move freely. So the entropy, the randomness of the system is going to increase. So delta S in this case is going to be positive, and I know if delta S is positive, then this one is going to be a spontaneous reaction. Okay. So another example over here, I am going now from two reactants to a product, right? So whenever you have more than one reactant, more than one product, I want you to count the molecules. So this is why it's very important to balance the chemical equation. So what do I have in here? What I have is 3 moles of gas molecules reacting. This is what I have. I have 3 moles of gas molecules reacting, and I am forming 2 moles of gas molecules. 2 moles of gas molecules. Okay, this is forming. So 3 moles of gas molecules reacting, 2 moles of gas molecules forming. So I'm ending up with less gas molecules than I started with. So in this case, the system is going to be less random in this case. So it's going to be negative. So I would say that this one is going to be a non-spontaneous reaction. So a non-spontaneous reaction here, you have to count your outcome versus what you start with. If your outcome is less than what you start with, because they are all the same physical state, they are all gases in there, then in this case, your system is going to be less random, and less random means a non-spontaneous reaction. So by definition, you guys always look at the physical state of the reactants in the products. If you are going from liquid to solid, then I would say that my randomness in this case, delta S, which is the entropy, that is going to be negative. If I'm going from gas to liquid, so gas is more, it's molecules, they move freely. So this is more random. Liquid is less random. So this one is going to still have delta S to be negative. So delta S negative is a non-spontaneous reaction. Okay, so that is a non-spontaneous system or a non-spontaneous reaction. Then if I'm going from a liquid to a gas, this is higher randomness. I am reaching the gas state, so delta S is going to be positive. Going from solid to liquid, higher randomness again. So delta S is going to be positive, and that will represent a spontaneous system or a spontaneous reaction, depending on what you are working with. Okay? Now, the term stable. So if you have a stable substance, what does that mean? A stable substance is a substance that, as the name says, it's stable. So you cannot change. It does not undergo spontaneous changes at existing conditions. So if you have a solid, it stays a solid in all conditions. It does not change into other physical states. Like, for example, I would say bromine. So here I'm showing 3 physical states of bromine. So bromine is not stable. Bromine is not stable because bromine normally at room temperature, bromine is a liquid. Okay, at room temperature, bromine is a liquid. You know that bromine is a diatom. So we draw bromine as, or we write bromine as Br2. So at room temperature, bromine is a liquid. Now, once you heat up the bromine, bromine changes to gas. So bromine is a vapor gas at a high temperature. And at low temperature, bromine is a solid. So this is why, comparing the 3 physical states in there, bromine can either be a liquid, can be a solid, can be a gas at different temperatures. So this is why I would say that the bromine is an unstable, or it's not stable substance. Again, a stable substance is a substance that exists at a certain physical state, no matter what the conditions are.